Greetings, Dr. Will here. Welcome back to the serialization of what you don't know, successfully lead a software project without tech expertise. Episode 15, Chapter 6, How Exactly Are We Building It? Analysis and Design, Part 2. Artifacts are any materials produced, documents, drawings, diagrams, code, during the system's design. The design model is used to both conceive and document the design. It is an abstraction of the implementation of the system. It includes the design classes, subsystems, packages, collaborations, and relationships among all of them. The culmination of this work is the software architecture document. It is a comprehensive overview of the system using different views, like the different drawings of a building architect, to depict the various important aspects of the system. The requirements view explores the requirements that have the most significant impact on the architecture. The logical view shows the various elements and structures of the software. A process view may be necessary to describe necessary parallelism among multiple entities and how they communicate and synchronize. The optional deployment view deals with how the various runtime components are replicated and deployed and how they communicate. The implementation view describes how the implementation elements are organized in the development environment. For example, the standards for the use of the version control and source code management system. Finally, the data view, if needed, describes the organization and connections among the critical data elements. Architectural choices have significant impact on the development of the system. Selection of the database system, deployment structure, and programming languages all affect how the system will be programmed. It is not unusual for these choices to be largely implicit and assumed. What technology is already known by the development team often becomes the de facto architectural choice. There is a chance that approach may work. Other roles may or should contribute to the architectural definition of the system. A designer, senior developer, works at a lower level of abstraction than the architect and fleshes out the critical details of architecturally significant components. They are accountable for details like the component's responsibilities, operations, attributes, and relationships. They also determine how the components must be adjusted to the specifics of the implementation or production environment. When the system has a significant database, a database designer is needed to design an effective or efficient database structure capable of responding to the application's data needs. This is particularly true of SaaS applications that often have a significant database component. Reviewers, especially the developers, review the key architectural engineering artifacts produced by the architect and designers. This is a good idea for several reasons. First, for quality reasons, the work needs to be reviewed for correctness, consistency, and completeness. Second, for training reasons, the developers who review the architectural artifacts are exposed to the architectural context in which they will need to program their components. Data or database design. Most SaaS products include a cloud-based database system that maintains and manages customer data. An area of particular architectural concern is the definition and organization of that database. Conflict may arise between an agile process that adds new features to the system on an ongoing basis and the need to define and tune the database. Continually reorganizing a database owing to continual changes in the data being retained in the system creates risks to the project during maintenance. More on this later. In the ready, fire, aim world of much of software development these days, all of this design discussion may seem to be far more ceremony than is warranted or affordable. An architectural design is undertaken specifically to address the most significant requirements, those that have the greatest impact on the system architecture, and to mitigate technical risks. Once done, there is a stable basis for the rest of the design and implementation of the system. Key technical risks have been shown to be manageable, and the understanding of the problem is more profound, producing more reliable estimates and plans. Detailed design. Detailed design can be considered to be the bridge between the design activities and the programming or development. It is usually done by the developer working on a module, although it may be done by a senior developer and then handed to a junior developer for programming and unit testing. A detailed design should be created when or if the module that is being worked on requires it. That would be if the specification indicates a level of complexity that warrants it, or, as mentioned above, if a junior developer will do the actual programming. Not every module requires pseudocode detailed design. There are simple CRUD cases. These are use cases that deal with simply creating, reading, updating, or deleting simply structured or accessed data.
Such cases are generally self-documenting. But no module requires a detailed design either. The use cases that deal with complex business logic or scenarios or data structures and relationships are good candidates for documented detailed designs. The pseudocode written and reviewed as a detailed design for complex situations should be converted to comments embedded in the code when it was written. The pseudocode describes what the code should be doing and, owing to its structured natural language character, explains the code. It may only become apparent that the module needs a detailed design after programming has started. The developer may become bogged down and the development may stall out because unexpected complexity is discovered in what was thought to be a simple module. In that case, the developer should step back, create a detailed design, have it reviewed, and then proceed with implementation. Note that this suggests a level of maturity on the part of the developer to realize that things are taking too long, and a level of organizational maturity to handle the cost and schedule shock of delayed development on that module. The architectural high-level design provides a set of components with defined interfaces. The components are further decomposed into lower-level structures that do the actual work of the component and conform to the defined interfaces. Several models can help here. Sequence and interaction diagrams detail how different modules work together to produce the specified result. A state diagram represents and analyzes how the data changes as the system operates on it. Exactly which models or diagrams to use depends heavily on the programming paradigm that will be used to code the system. An object-oriented language or paradigm will use different models than a structured or functional language or paradigm. One of the most powerful artifacts produced in detailed design is pseudocode. It is a natural language-like description of the steps the module must perform to perform its function effectively. This is just short of writing the actual code and is used to express the algorithm, the sequence of processing steps, so that it can be reviewed for correctness before the additional work of expressing it in the programming language in the code. Some things are easier to do in some languages, some things are harder. The pseudocode abstracts the programming language-specific details from the consideration of the algorithm, putting the focus on the semantics of the problem rather than its syntax. All of the foregoing, requirements, analysis, and design, seem like a lot of effort before any actual code is produced. As already noted, it is not unusual for owners or senior managers to suffer from the WISCY whiskey syndrome. If it were a building, then the equivalent would be the unpronounceable WISPCY syndrome, which is why isn't somebody pouring concrete yet? Well, the ink is still wet on the contract. It's tempting to think that new agile software development methods can deliver a working, functional system without any of the elaborate, expensive requirements and design activities described. It is true that a system that mostly kind of works can often be developed without documented designs and written requirements. It is also true, however, that such a system will become increasingly difficult to sustain and ultimately need re-engineering. More on that later. Agile methods are no excuse for shirking engineering. The better Agile practitioners are good engineers and are selective about the kinds and amounts of ceremony. That means rational choices are made and documented, not that all such activities are skipped.
That ends Chapter 6, How Exactly Are We Building It? Analysis and Design. Join us next time for Episode 16, Part 1 of Chapter 7, Making the Abstract Real, Code, Test, and Deploy. That's it for me for you for now. Be careful out there. Bye.